Okay, welcome to this quick showcase of the NodeParser. Before we start, what is NodeParser? NodeParser is a parser system built upon Irony. Irony is a parser library for C#, for .NET, however you wish to call it. So why does a NodeParser exist? Well, Irony is a great parser, a fast parser and whatnot. It kind of lacks in the entire encapsulation and maintainability department. You just end up smashing everything in one big class, and then you have a whatever 2000 lines long God class that handles all your parsing and scanning. I didn't like that, so I decided to build upon Irony and build a parser library. Parser library has been finished by today and is called NodeParser. I'll do a video because my scripting language or programming language SoulScript now depends on a NodeParser, and if people decide to use SoulScript or modify it for their projects, they probably may wish to know how the NodeParser works. So first of all, where can you get the NodeParser? You can get it in my Bitbucket project or Bitbucket repository page. It's probably linked in the video description. So how do you get started with the NodeParser? I decided to fire up the source code of SoulScript because I'll show you a real world example. We'll not build a stupid hello world example which has no practical use whatsoever. So when you get started, you want to create a new grammar class like you used from Irony. You derive from a node grammar, which in itself is derived from the Irony grammar, so you're still able to use the grammar explorer and whatnot to inspect your grammar, which is really useful. And then you're pretty much only required to override one thing, or two things for this case: the type of your root node, and you want to create a comment terminal. The comment terminal are created at the base level. So what's this root node? As the name suggests, everything in the node grammar or in the node parser is a node. Let's get right to the root node. Actually, let's just jump to definition. Boom. You derive nodes from a parser node, and then you have a generic argument. We'll get to that later. And oops, I need to uncomment that, but that's irrelevant for now. You implement a rule, which is a BNF expression, an Irony BNF expression, which is exactly what you do before if you were to declare your non-terminals and whatnot. Only this time you define it in your node. And right beneath the node, you scan the node or interpret the node however you wish to call it. And this node is then translated or transformed, as I like to call it for the node parser, into a type. In this case, it's an enumerable of a sole definition. A sole definition for this class can be a function, a class, or, well, a field, but for some reason I decided to uncomment that or comment that. Oh, look at that later. So what can this be? I added a shift hint here, probably for a reason, then a function, then a node for a function, a node for a class, and we'll make a list out of that. I hope if you're watching this you're somewhat familiar with the Irony system, but the plus means we wish to combine those two. So we're shifting and then have a node of a function, then or a class node. We make a list out of it. The node parser kind of uses a new syntax. So instead of being able to write like new key term, my term blah. Oops. Well, you get the idea. You only use these fully uppercase nodes or methods. You really only want to use the fully uppercase ones. It will most of the time work fine if you use a different syntax or inject some Irony stuff, but you can do everything using the syntax provided by the node parser. Just treat it as if it would be a completely new system. So let's say we want to force the user to write a hello world at the beginning of every file. We go ahead and say, should it be a keyword? No, it'll be a term. Now the user would be forced to write hello world at the beginning of every file. But let's get into the node stuff. We have another node here. So node sol node class. Here comes the really beneficial point of the node parser. We can actually nest nodes inside of each other. So right here we have another node parser node, which is a parser node for a class definition. And what is the rule of this class definition? Well, we have a node of annotations, which are, if you're familiar with Java, this will look familiar to you, in which we have annotations above our class. This annotation is annotation, and a second annotation with some arguments, third annotation. We'll look at the annotation node in a second. Then we have a class modifier, which is in this case abstract, but the class modifier is optional. We don't have to include it. Then we have the keyword class right here. Then we have an identifier node, in this case test class. Then we have a node of members, of class members, and we'll make a list out of that. And it's a star list, meaning we can have 0 or more. And then all the way to the end, we have the end terminating this class definition. So how do we, let's get rid of this old legacy stuff. Okay, so how's this parsed? Okay, we now have to override the build and get node method, which gives us an array of IAST nodes, an array of AST node interfaces, because all nodes implement this interface at a very low level. Because if you look at some nodes, we'll look at that later, but for example, key terms don't implement a parser node. A parser node are essentially just your non-terminals, and some classes may implement something else entirely, so it's just an IAST node, but you can easily work with it. So how do you obtain our annotations? Our annotations were defined in the first AST node, in this first rule. So we get the 0th AST node as, this is essentially just a wrapped cast, because you'd end up wrapping casts inside of casts. Normally this is a very bad syntax or very bad way to do casting, but for this case there's an overload provided just for the IAST nodes to cast them this way. So we cast them to a list node of sol annotation definition. We saw here we have a node of a sol annotation definition and then made a list out of it. So now we have a list node of sol annotation definition and we get the value of it, and boom, we already have an enumerable of sol annotation definition. No fancy magic involved, we don't have to do anything special. This is how it works. But now, how do you do these things? Does the sol annotation, sol node annotation suddenly create a sol annotation definition? If you're not familiar with Sol script, these names sound very similar, but if you look at that, this is a node, essentially the same to a sol node class, and the sol node annotation produces the sol annotation definition, similar to this parser node creates a sol class definition. So how is this sol annotation definition created from that node? Well, let's take a peek at it. Let's just literally take a peek at it. We could do the same thing as before. We have a punctuation term, an add. Then we have a, let's actually fire that one up, an add. Then we have an identifier. Then we have braces, opening with this opening bracelet, closing with this closing bracelet, and then a brace. Then we have a node of an expression, meaning that can be a function call, can also be a string literal, can be a number literal, whatever. And we make a list out of it. And all of these list elements are separated by a punctuation, which is a comma. And it's a star list, and we can also have the delimiter, this comma, at the end. So this is what it ends up, an annotation. Oh, and also these braces are completely optional. So we can have an annotation with nothing because the braces were optional. We can have an annotation which includes one expression, which in this case is a string literal. We can also have an empty one. We could also have the trailing delimiter, or we could also have even more expressions. Let's actually add the trailing delimiter here just to, whatever. So yeah, that's how it goes. So now we have the build and get node. Even more legacy stuff, let's kill it. Boom. So we have the 0th AST node, which is an identifier node, and we get its value. Punctuations do not get any AST nodes, so you can ignore them. So in this case, it is the 0th. We cast it to a term identifier node and get its value. The value of an identifier node is always a string. So let's actually look at the identifier node once again. And this is already deep down into the library itself, but as you can see, this one derives from IAST node and nowhere from a parser node. So there we go, we get its value. And then we get the braces node, which is the first. This was 0, this is first. And this is optional, so we cast it to an optional node. And then we get its value. And if the node doesn't exist, because it was optional, we return an empty enumerable instead. And this thing is essentially the exact same thing again, sol node expression. We have all of these things again, it's built, and then we get its value and cast it, and so on and so forth. So we just end up wrapping node inside of node inside of node. And the great thing is, each node is scanned or handled or transformed, again, however you wish to call it, right beneath its definition. It's all very clearly encapsulated. And if you wish to change something, you only have to edit one single file and everything else will just continue working. Because you didn't have to hard code any string switching or whatnot, because all of that dirty stuff is handled for you behind the scenes, which is really easy to use. So now that we're done here, we obtained our annotation definition. We're back in the class, by the way. We obtained our type modifier, the abstract. We obtained the name of our class, and we obtained the class members, which by itself is already a node again, which can be a field or a function. And once that's built, it gets the 0th AST node, which is either in this case a field or a function, and we got its value. Let's actually use nicer system syntax in this case. Again, just syntactic value sugar provided to save you from casting 500 times inside of these thingies, because if we would cast here, we'd actually have to cast this to an optional node, and we have braces here, then we have to do get value, which would be an object, and then we'd have to cast, and then we'd have to switch if it's null or not, and unbox it, and then get this. So this is just much nicer syntax. So now we have everything. We have an annotation, type, mode, name, member, and then we can just use whatever way we use. We can call our factory methods, we can call our constructors, and whatever we wish to use to create our classes. In this case, we create a sol class definition, which is already a class in the interpreter. So in this case, we already leave, or in this case, we already transform our parser stuff into our actual runtime data. So we create a class definition for the currently parsing assembly at the location, which is also really handy stuff, which is, I'm aware that there's another library for irony, which is called sarcasm, but I didn't like it for several reasons. First of that is, you can't just write this of a complex, well, transformation code to transform your parse nodes or your AST nodes into your actual data. You have to be happy with very basic stuff. And there was also very bad handling of debug locations. Every single code location was stripped from your data, which it isn't in this case. We can do this and location, and we have a location that tells us the index, our column index, the file index, line index, and even the file name our data was in. So the NodeParser is excellent handling for debugging stuff. There won't be any problem by being able to locate this stuff in code, and also whatever to provide stack traces for users in case something goes wrong. So, create a class definition. Type is the name of our type. The type mode is our type mode, and then we inject every single member into the class. I still need to add some validation stuff here, but SolScript is still in development, so that's a non-issue, and you can do that however you wish. Then we inject our annotations, and we just return our class definition, and now the node can be used inside another node, which it has been, a root node, which is exactly what we're doing here. Once everything has been parsed, we go through every single child node of this list, because the 0th node in this case is a list of either a function, should be a field, and a class, and they all inherit sol definition, which is the base class for every definition in SolScript. We iterate through them and yield the value of that. And once all of that is done, once we're already here, yes we are. Well, let's actually run it. Boom, okay. And what happens now? We build the grammar. Grammar in this case, we're already deep inside the SolScript stuff. This is no longer necessarily directly related to the NodeParser, but it's just showing you how to use the NodeParser. Grammar is the source script node grammar, which is lazily created. We build the grammar. You always have to build your grammar before doing that. Once the grammar is built, you can't modify your AST nodes anymore. Well, you technically can, but if you do, things will blow up and be extremely horrible. But most of the time, your AST nodes, or not most of the time, I see no reason or no use case in which you wouldn't hardcode the rule. Because it's still a property after all. You could just call a method and then whatever return a rule based on a random number generator. So that each time you call you run your method, the syntax is different. Well, actually, I know a language that does that. There's actually an esoteric programming language that changes its syntax like every day. I'm getting off topic. So you build your grammar, which does fancy stuff behind the scenes for you. And then once that is done, once your grammar is built, don't mind all the error handling here. Right now, only that is relevant. And once your grammar is built, you go through your source files or source strings, however you want to do it, and parse it. Well, let's actually go to the source files. We read all text of the file name. Could have a bunch of errors. And then tell the grammar to parse the given text, which was taken from this given file name. And then we can specify the error level, so either warning, error, probably several different stuff. Also info, yeah, okay, just for completion. And this install node root is this node, because we specify that this is the root node, so that is exactly what this grammar will produce. It will produce as a root node. And if our root node is not null, it will be null if a critical parser error occurred. We add it to our parse trees or to our successful data that was parsed. We obviously catch an exception. The main exceptions, the main parse method throws a NodeParser parse error exception. That sounds horribly convoluted, but makes sense. NodeParser parse error exception. It's an exception that tells us that a NodeParser has a parser error. But yeah, exactly. But the exceptions are documented, so there's none. That's not an issue. And once we parsed every of our files, we go through every tree. The naming tree is still a relic from back then when I was using parse trees directly from Irony. We go through every root node and extract every sol definition. If the sol definition is a class definition, we register class definition. If it's a field definition, we register a global field. If it's a function, we register a global function, and so on and so forth. And that's how easy the NodeParser is. It probably sounds a bit confusing at first, and I won't blame you because it may take a minute to get the hang of it, but it's really powerful. Let me actually continue. Yeah, okay, no error. Just wanted to make sure. And the biggest part of learning the NodeParser is probably which types your node will actually end up having. Because what's this? We have optional braces that wrap a list of a node. So do we now have an optional node, a braces node, an enumerable of sol node expression, a read-only list of sol node expression, a list node of sol node? What do we have to use? Well, typically, it actually doesn't matter. There is actually, you could, for extracting these arguments, you could legitimately do AST nodes 1 get value oh, what did I press? No, okay. We could legitimately do that. The NodeParser is very forgiving when it comes to that. But in this case, I like to be a bit more explicit with my definition. So I take the first AST node, which is this one, punctuations doesn't count again. And we start indexing at 0, so this is the first. We take the first node, which, if we would write it in one line, we just look at the method call chain. It first creates a list, a node, and then wraps that node in a list, then wraps that list in braces, then wraps those braces in an optional thing. So the node is an optional node. You can typically just go by that. Boom. Okay, you can just go by that. And then If you're still unsure, you can actually just take a peek at these thingies. And these things also have an init method. They are a bit more complicated, stuff like the optional node, braces node, or default AST node. They are a bit more complicated because they really wish to make sure that it's just really easy to handle. So what this does, if we'd have a million different nodes wrapped inside of here, they try to unfold the nodes as much as possible so that you wouldn't have to add 3 indexes after another, which would all index to index 0, because you'd have 500 different nodes with just one element in it, which would be its child node, because it just unstacks various stacks. So we'll never have to use more than one indexer in a row. So it's really easy to use for you. That's also the reason why we can't actually get the braces from here, because the optional node notices that we only have one child node, which is the braces, and thus unstacks the braces and actually adds in the value of the braces into the optional node. The braces node also noticed that it only has one node inside of it, which is the sole in the list of expressions. So it also added that into this. So all we need to do is to get the optional node. So that's basically just that. It can be confusing at first, but it's really powerful once you get the hang of it. You can always just take a look at the soul script grammar, which is inside the soul script parser nodes directory or namespace. And you can just peek through that and get a hang of how to use the NodeParser. It's a really powerful concept. So if you, how long are we? And we're already way overdue, so whatever, let's just keep talking. What we also had at the beginning of the video, let's actually just undo a thing or two. Yeah, whatever. Let's just find a different class. Let's just find a different class. There we go. No. It really doesn't matter. But what some people probably also may have an issue with is the indexing, and they'd wish that there was some sort of easy identify system that we could directly map the node, whatever, to a delegate or an ID even to do that. That was actually something that was supported initially, but then got dropped for several reasons. It had more issues to be worth it. And also, the mapping stuff to a delegate, it's what I learned from using sarcasm, or just easily directly mapping properties doesn't really work for more complicated languages. It works really easily if you just are programming a pocket calculator or whatnot, or trying to write the syntax for a pocket calculator, or a really straightforward procedural language which only has a bunch of expressions, but it just doesn't work for an object-oriented language which uses some really heavy nesting. It doesn't work because your NodeParser nodes don't always one-to-one correspond to a property inside your classes. For example, if we take a look to how the if node, kinda, if a conditional, right? If we take a gander at how the conditional statement is done here, we have an if, then an expression, then it looks very familiar to Lua. Well, actually, let's fire up Notepad++. If an expression, then else if an expression, then else end. If we take a look at how this is structured, we have if, then a chunk is just a bunch of code, then an else if node, else if an expression, and then chunk, and we make a list out of them, else a chunk, which is optional, end. So we have the if and the then, or the if and the else if separated. But the actual conditional statement just has an array of if branches. Don't mind the generic array, it's just a thing SoulScript uses in order to encapsulate stuff into a read-only list. Which it actually just uses an array of if branches, so that it doesn't really differentiate between if and else if. It's just if this, do the chunk. If this, do the chunk. If it just continues trying to do that, iterates through the if branches and executes the first one, in which the condition evaluates to true. So more often than not, your parse nodes or your AST nodes don't correspond one-to-one to how your data, how your language actually looks like, which is one of the reasons why such a syntax is not provided. No, that one. So yeah, that's basically that. I do want to add a wiki for the NodeParser, but I'll have to see, because my priority for the minute lies in SoulScript. I want to get SoulScript operational, or well, it is operational, but I want to get SoulScript to a point where we can honestly say this is a full release, it's feature complete, it's to the best of my knowledge bug free, and it shipped. Have fun with it. Well, it's already shipped, but it's in a good condition. I want to get that first and write the wiki for SoulScript, and then I'll probably revisit the NodeParser, write its wiki and whatnot. So if you have questions, just contact me by email or just drop a comment. You can find my email on my blog, which is also on my website, and then under contact or about me, whatever. So that's that. I hope you enjoy the NodeParser, give it a shot if you use Irony. I don't make this claim often, but I'm pretty confident that it will ease your workflow, that will be an improvement over what you are using right now with Irony. So that's that. Enjoy.